Hello everyone and welcome back to our Python learning journey. So far, Alex learned about variables, data types, operators, strings and lists. Now, Alex knows how to store data. But now comes an important question. Does Python provide different ways to store collections of data for different situations? The answer is yes. Today, Alex will learn three powerful data structures in Python: tuples, set, and dictionary. Each one has different purpose. Understanding when to use what is a huge step forward in programming. So let's begin. Alex notices something interesting. Lists are powerful. They can store multiple values. They can be changed. But sometimes data should not change. Duplicates should not exist. Values needs meaningful labels. Using list everywhere is not always the best solution. That's why Python provides different data structures. Each one solves a specific type of problem. Alex starts with tuples. A tuple is very similar to a list. It can store multiple values in a specific order. But there is one key difference. Tuples are immutables. That means once created, they cannot be changed. Tuples are defined using round brackets. Alex wonders, why use something that cannot be changed? Then he understands tuples are useful when data should stay constant and values represent fixed information. For example, days of the week and coordinates, configuration values, etc. Tuples protect data from accidental modification. Even though tuples cannot be changed, their values can still be accessed. Just like list, tuples also use indexing. Indexing works in the same way, starts from zero and supports negative indexing. And let's now compare lists and tuples. Lists are mutable, tuples are immutable. Use a list when data needs to change. Use a tuple when data should remain fixed. Choosing the right structure makes programs safer and cleaner. Now Alex learns about sets. A set is a collection of unique values and unordered elements. That means duplicates are not allowed and order is not guaranteed. Sets are defined in curly braces. Duplicates are automatically removed. Alex realizes something sets are perfect when uniqueness matter and duplicates must be removed. Like as in real life example, unique user IDs, unique email addresses, or unique tags. Sets help keep data clean. Sets are mutable, but they work differently from lists. Important things to remember: sets do not support indexing. Items have no fixed order. Now, Alex discovers what makes sets truly powerful. Sets are not just about removing duplicates. They support mathematical operations, which help compare and combine data in very efficient way. Let's understand these operations one by one. Union. It is for combining values. The union operation combines all unique values from both the sets. Union answers the question, give me everything but without duplicates. This is commonly used when merging data from multiple sources and combining permissions or tags. Intersection. The intersection operation returns only the values that exist in both the sets. Intersection answer the question, what is common between these two? This is useful in finding common users, matching scales, or filtering overlapping data. Now the difference means removing overlap. The difference operation returns values that exist in one but not in the another set. These answers what is unique to set A. It is gets used when removing unwanted items or filtering exclusions. Set operations are fast, readable, and very efficient. That's why sets are heavily used in data processing and analytics. Finally, Alex reaches one of the Python's most used structures, dictionary. A dictionary stores a data as key value pairs. Instead of index number, values are accessed using keys. Alex now understands why dictionaries are used everywhere in Python. Dictionaries store data in key and value pairs. This means every value has a meaningful name. Instead of remembering positions, we work with the names. This makes programs easy to read, easy to maintain, and closer to real world logic. Think about real data. Student name, age, course, city. All of this is best represented using dictionaries. This is why dictionaries are backbone of real application. Now, Alex starts working directly with dictionary data. To access a value, Alex uses the key. This directly returns the value linked to that key. Dictionaries are also mutable, so Alex can update values easily. Now the age is updated. Alex can also add new data by assigning a new key. This flexibility makes dictionaries perfect for dynamic data. Keys must be unique. If you refuse a key, the old value will be overwritten. Alex now explores some very useful dictionary methods. These methods help us inspect and process dictionary data. Keys method. It returns all keys. It is getting used when validating input and looping through the fields. Then values. It returns all values. It uses when we are checking data and performing calculations. Then the next method is items. It returns all key value pairs together. This is the most commonly used method when looping through dictionaries. These methods do not change the dictionary. They only help to read and process the data. Alex now looping through dictionaries. This pattern is extremely common in real-world Python programs. Now Alex clearly understands why Python has multiple data structures. Each one solves a different type of problem. Let's compare them clearly. List is ordered, mutable, and allows duplicate. It gets used when data changes frequently and order matters for us. Tuples. Tuples are also ordered but immutable. It is getting used when data should not change and values represents the fixed information. And then comes to set. Set is unordered and maintains unique values only. It is gets used when duplicates must be removed and comparison is needed. Dictionary, key value structure, and fast lookup. It is getting used when data needs labels, real world entities are modeled. Choosing the right data structure is not about syntax. It's about clarity, safety, and performance. That's what separates beginners from confident programmers. Let's summarize today's session. Today, let's learn tuples protect fixed data, sets removes the duplicates, and dictionaries organize the data with keys. This knowledge takes Alex one step closer to real world Python programming. In the next video, Alex will start working with conditional statements. We will learn if, elif, and else. That is where programs start making real decisions. Until then, practice these data structures and try small examples. I will see you in the next video.